Hey guys, so in today's video I'm going to show you how to name simple alkanes. So for organic compounds we usually have two different names. The first is the common name, and that name comes from the historical usage of this specific compound, and it would be easier if you guys remember this as the nickname of the compound. These systems are obviously non-systematic, and that's actually a drawback because we cannot use them to describe larger and more complicated molecules with many isomers. And then we have the more systematic naming, the IUPAC naming, and the IUPAC stands for the International Union of Pure and Applied Chemistry. And this system is systematic and gives the chemist a step-by-step process to describe the organic molecule. IUPAC naming is pretty much like any naming system. So in our naming, we have first and last name, and I'll use myself as an example. My first name, Mohammed, and my last name, Heiko. That was just my name during my childhood till I became an adult. When I became an adult, I began to have a prefix, and this prefix is Mr. And then as I went to college and when I graduate, I'm gonna have the suffix of pharm-d. That's my function, that's gonna be my job. The same idea applies to organic chemistry. In organic chemistry, the first name is made out of the number of atoms in the parent chain, and the last name is the type of hydrocarbon chain. And together, the first and the last name makes up the parent chain. And then if that parent chain has any branches, we add that in the prefix. And if it has any functional group, we add that in the suffix. By functional group, these are like it's different atoms. It's like OH, CO3. It depends. Like we have many functional group like an alcohol, carboxylic acid. All these are functional groups that adds on. But for now, you don't have to worry about that. We're gonna discuss this later on in later videos. Naming simple alkanes. So simple alkanes are just the parent chain. So the name will be only the first and the last name. The first name will be, as I said, made out of the number of atoms in the parent chain, and for each number, there is an identifier. So for number one, we have meth. For number two, we have F, and three, we have probe. Four, we have but, and five, we have bent. Six, we have hex. Seven, we have hep. Eight, we have oct, and nine, we have none, and 10, we have dec. For the last, we have the type of hydrocarbon chain, and in this case, since we have an alkane, we add A and A at the end. Now let's do an example, and I'm gonna have the table right here so you can look at it, but you have to memorize it for the exams. So let's say we have this compound right here. So the first question, or the first thing we gotta do once we see the compound in order to name it is to count the number of carbons. So now let's count the number of carbon in this compound. It's 1, 2, 3, 4, 5, 6. So let's look at the table. 6 is hex. Then we add hex. Type of carbon chain, since it's all single bonds, it's an alkane. So we can add A and E at the end. And now we ask ourselves, do we have any branches in the compound? And the answer is no, since it's a straight chain, doesn't have anything coming up from it. Is there any functional group and like any atom other than CNH? I don't see any atom other than CNH, so the answer is no. That gives a final name of hexane. Now let's do another example. We have this compound right here, but this now in the condensed structure formula. The first thing that we gotta do as last time is count the number of atoms. We have 1, 2, 3, 4. That gives it but. Now, type of carbon chain in this case is not drawn out, so we can tell by single bonds. So we have two methods in here to determine if it's an alkane or alkyne or alkene. So we can either use the formula CnH2n plus 2 and test if it's an alkane or not, or we can draw it out and determine which one is it. Right now I'm going to use the formula. So in here we have the number of carbon n equal to 4, and in order to determine the number of hydrogen we multiply 4 times 2 plus 2, that gives it 10. So we anticipate that we have 10 hydrogen atoms in the compound. Now let's count the number of hydrogen we have. It's 3 plus 2 plus 2 plus 3, that's 10. So this compound has to be an alkane. So we can add A and E at the end. Now, is there any branches? If we can draw it out, and since we're not gonna find any branches, and since the number of hydrogen and the carbon matches exactly, there is no branches in this compound. So the answer is no. And is there any functional group, any atom other than C and H? The answer is no. It's only C and H in here. That gives the final name of butane. Thank you for watching, and please, if you have any questions, leave it in the comments below, and don't forget to subscribe to the channel. Thank you.